Yes.
Ma'am, I'll just leave the meeting and join again.
Fine. Uh, Boss, so far you have learned about motion of a body in a horizontal circle, right? Horizontal circle in that sense. Suppose if you tie one end of a string to a stone, the other end of the string you are keeping with you and you are whirling it in a circle, right? This is called a horizontal circle. So far, you have learnt about motion of bodies along a horizontal circle. Horizontal circle in that sense, the plane of the circular path or the plane of the circle is horizontal. Now, look at these examples, that is especially in a roller coaster, you can see the bodies are moving in vertical circle. The plane of the circular path is vertical. Now, this topic is all about motion of a particle, motion of a body, which is moving in a vertical circle. There is one concept, what we call it as looping the loop. Looping the loop is that, can you see this in this vertical circle, right? Right. Now, at the highest point, so in a circular loop, there are different points. One, what we call it as the lowermost point. The other one, we call it as the highest point. Now, at the when the body reaches the highest point, right, you could see the people traveling in a looping this loop. Now, when they reach this highest point, they don't fall, right? Even though the gravity, its own weight is acting in the downward direction, they do not fall. For example, you take a bucket full of water, you whirl this bucket full of water in a vertical circle, right? Now, if you whirl it with a certain velocity, what we call it as a critical velocity, right? Was if you're whirling a bucket full of water, say you are whirling a bucket full of water in a vertical circle, not in a horizontal circle. So when the bucket reaches the highest point, water will not spill. Now, this can happen only in certain cases where the velocity with which you swirl the bucket with water is say a certain velocity, what we call it as a critical velocity. So if you swirl the bucket full of water in a vertical circle with a certain velocity, what we call it as a critical velocity, water will not spill. Now, this process we call it as looping the loop. So, your aim is to study what happens when a body moves in a vertical circle and what might be the condition so that the water will not spill out of the bucket when the bucket reaches the highest point. That is what we call it as the looping the loop. Okay, right, boys. Heading motion in a vertical circle. Motion in a vertical circle. Anyway, I'll take up an empty slide, and because this diagram, what is being shown, is a culmination of all things. So let us start with. It will be difficult for you to understand. I'm just taking up an empty slide. Was suppose, right? You have a string, right? One end of the string, right? You're holding one end of the string, say the free end of the string. The other end of the string, say you attach it to a stone, say of mass m. That was. So now you are swirling it in a vertical circle. Like, can you imagine like this, right? So you have a string, the free end of the string, you're holding the free end of the string. The other end of the string is attached to a stone, say of mass m, and you're whirling it in a vertical circle. Clear, boys? Now, when the body moves in a vertical circle, now let L be the lowermost point, H might be the highest point. I'm taking two different points when it is moving in a vertical circular loop. L is the lowermost point, H is the highest point. Now the length of the string L becomes the radius of the circular path. 11b, 11b, are you there? First period.
Yes, ma'am.
Okay. Are you still sleeping? 11th standard?
No, ma'am.
Okay, fine. So the length of the string becomes equal to the radius of the circular path. Are you clear? Now, let us consider at any point, sorry, at the point, lowermost point L, the velocity of the mass is m. The velocity of the stone is m. This is what you are considering. At the lowermost point, the velocity of the mass is, sorry, the velocity of mass m is u. At any point, say when the stone reaches point P, let its velocity be equal to v. So I'll take the central point O. The length of the string becomes equal to the radius of the circular path. So when the body reaches point P, its velocity is v. So, fine. Right. Now there might be two different forces acting on this mass. So I have a body, a stone. So I'll take this point as your stone. So there will be a tension acting along the string, which is acting towards the center. So at point P, the mass is having a velocity v, and there will be a force acting along the string towards the center. We call it as the tension. So I'll repeat this once again. You're holding a string, the free end of a string, say of length L. The other end of the string is attached to a stone, say of mass m. You're whirling the stone in a vertical circle, right? So when it whirls in a vertical circle, the length of the string becomes equal to the radius of the vertical circle. I'm considering two different points, the lowermost point and the highest point. At the lowermost point L, the object, say it is moving with a velocity u. So when it reaches any point, right? Say if it reaches point P, the velocity, I'm taking it as v. So when the body reaches at point P, there will be always a tension which is acting along the string, which is always directed towards the center. So now I think you'll understand this diagram. When it reaches point P, boys, the stone is moving in a vertical path, right? So when the stone reaches point P, it is having a velocity v. Can you see this, boys? When the stone reaches point P, it is moving with a velocity v.
Yes.
And T, okay, at point P, there is a force acting along the string. Now, can you imagine OP will be your string? Yes? Because at OP is your string, at point P, you have a stone of mass m. Here I'm just considering a stone of mass m. At point P, you have a stone of mass m. Now it is moving with a velocity v. At point P, OP will be your string, right? So the force which is acting along the string, we call it as tension T. Now when the stone reaches point P, its own weight is acting in the downward direction, right? Its own weight is acting in the downward direction. So I'm repeating this once again, boys. When the stone reaches point P, it has a velocity v, right? At the same time, OP will be your string. There will be a force acting along the string, that what we call it as the tension. Now this point P, this is your lowermost point, right? L is the lowermost point, H will be the highest point. Now this point P is at a distance of, or it is at a height of H above the point L. Now we'll take this point L as your reference point, right? Point P is at a height of H above the lowermost point. Boss, this derivation might be, if, for the first time when you're solving this derivation, or when you're doing this derivation, it might be difficult. So understand this. This point P is at a height of H above the lowermost point L. Clear? Now look at this. The string OP makes an angle theta with the vertical, which is your vertical. The line which passes from H to L, this will be your vertical. The line which passes through the points H and L is your vertical. The string OP makes an angle theta with the vertical. Is that clear? 11B. Boys, you're still sleeping?
Yes, ma'am. Yeah, can understand.
So the string OP makes an angle theta with a line which passes through the point H and L. Now, mg, the weight which is acting vertically downward, is resolved into two components, right? Can you identify these two angles theta? Why they are the same? Why these two angles are the same? Can you, mathematics students, now why these two angles are the same?
Ma'am,
Parallel lines.
it's parallel.
Okay, parallel lines. And okay, the line which extends through OP is your transversal. So there is no issue of these two angles being the same. Okay. So now,
corresponding.
yeah. Now this mg, I'm resolving it into two components. One is mg sine theta. The other one is mg cos theta. Is that clear, boys? So what I need to specify in this diagram, I need to specify this is the lowermost point. This will be the highest point, H, and the point where P strikes the vertical is N. Okay. Only these things. So draw the diagram, boys. Draw the diagram. Those who have completed.
Ma'am, we are right now. We started motion in a vertical circle. Yeah, so this is what I have to write like first.
This is what we call it as introduction. So boys,
Okay.
it's not necessary. Please understand. You need to write the introductory part. It can be in your own words, right? Are you clear? Consider a body of mass m tied to one end of the string.
No. What I'm asking is, this is the first thing we wrote. We're writing since we started this subtopic. Yeah.
Yeah, correct.
Okay, ma'am. Thank you.
Statement should be there, boys. All these statements should be there. It can be in your own, you can write it in your own way, not necessary whatever I have stated, but all the key points should be there. Now, how will you start? Consider a body of mass m tied to one end of a string, or else even you can leave those statements. You just can write, consider a body of mass m moving in a vertical circle of radius r. At the lowermost point L, let its velocity be equal to u. At any point or at any point P, let the velocity be equal to v. So all these things has to be specified. So you can write it in your own words. Diagram is important, boys. You should understand the diagram. Have you completed?
Ma'am, I really didn't understand one thing.
Which one?
Ma'am, in moving from L to P, how will it move in a height of
It
Ln?
has traveled a
Because
distance
it's moving in
a vertical height of h.
Yes, ma'am, but how?
When
Isn't it moving in a circle?
moved,
So won't we have to measure the length of the arc, right? Not the height, because it's moving in a circle, right?
okay, correct. Length that becomes equal to your distance traveled. So what you mean
Okay,
is
so
when
here
you
it's
measure the arc,
displacement, right?
arc length becomes arc length becomes equal to the distance traveled. What you say is from L to P, the arc length measures your distance, but from L, it is at what height is the point P with respect to L, vertical.
Oh,
It's not the distance. It's not the distance. If at all you, if I write the statement as distance, then it becomes the arc length. Clear?
Ma'am,
Bus, yes, what happened?
ma'am, if we take P a bit more higher up in the circle, then will those two angles still be equal? Like it will be
Okay.
not
Okay,
equal, right?
fine, fine. In that case, we still move. Still, it will be the same. Okay, we'll go for this. Suppose PS, which let me try this. It reaches say this is the point P, right? Still more higher you wanted. That's what you tell. You're stating, right?
Yes, ma'am.
Then should we resolve MG? Should we resolve MG? Just tell me, should we resolve MG?
No, ma'am. That's around the.
Not sure.
Not sure. Just you put the diagram and check. When it reaches point P, what is this angle, boys? This angle becomes equal to 90 degrees.
Yes, ma'am.
Then this becomes your velocity V vector.
Yes, ma'am.
Okay. Even if I want to resolve, now how will I resolve? Because
Okay, you can't solve it. Okay, ma'am. I understood.
that's at different points. Shall I move for the next one, boys?
Ma'am, can you remove? Oh, no, nothing, ma'am. Nothing, ma'am.
Now, first case, there are different cases. We'll go case by case. Now, when the body reaches point P, I want to find the velocity V. Is that clear, boys? The next subdivision is when the body reaches point P, I want to find what is the velocity V. For that, what we'll consider is when the body moves in a vertical circle, right? Now, at every point, I'm taking L as your reference level. L is your reference point. Say when you study about your gravitational potential energy, starting with your gravitational potential energy, say the body was lying on the ground, right? Now that was your reference level. Now what you have done is you are raising the body to a height h above the ground. The body was initially lying on the ground. You have lifted the body and raised it to a height h, which means work is done by you. Whatever work you do is stored as an energy. Now your ground becomes your reference level. Once your ground becomes your reference level, from your ground to what height the body is going to lie, that gives a measure of your potential energy. Suppose if you still raise the body somewhere to a height 2h from the ground, then the potential energy will be more. So your ground level will be taken as your reference level. Same way, when the body moves in a vertical circle, your lowermost point is taken as the reference level. All the heights you're going to measure from the lowermost point. Okay. So when the body is at the lowermost point, or when the body might be at any point P, the total mechanical energy in that sense, potential plus kinetic. See, when the body is moving, it has both potential and kinetic. Why potential? Because you're considering point L as your reference point. From point, suppose if I have the body reaches a point Q. Now, when the body is at point P, it is at a height h with respect to L. When the body reaches point Q, it might be at a certain height from point L. Yes or no, boys? When the body moves in a vertical circle at different points, right? The points might be at various heights. The point might be at various height from the reference level L. Clear? So now your aim is to find what is the velocity when the mass reaches the point P. For that, what we'll do is let us equate the total energy. What is the law of conservation of mechanical energy? You just learned. What is the law of conservation of mechanical energy? See, when you're dropping an object, a free fall, when a body is falling under the influence of gravity, at each and every point along its path, Your kinetic and potential might be different, but the total energy remains the same. Haven't we derived an expression for that, boys? When you're dropping an object from a certain height, what we call it as a free fall, as the body is falling down, at each and every point, your potential might be different, kinetic might be different, but say at point A, at point B, at point C, kinetic and potential might be different, but the total energy remains the same. That's what we have proved. Same way, at point L and at point P, their total energy will be the same, mechanical energy, but kinetic and potential are going to be different. Now, this work I'm asking you to do. Let me see how far you people are going to do. So what you can do is that velocity at point P, write the subheading, velocity at point P, velocity at point P. So then you can write total energy at point L must be equal to total energy at point P. So total energy means it will be kinetic plus potential, right? Shall
Yes.
I call it? Okay. Harish? Harish?
Yes.
Harish, at point L, anyway, I have not specified it here. Harish, at point L, what
Yes.
will be the kinetic energy of the stone at point L, lowermost? At point L, what will be the kinetic energy of the stone?
Kinetic energy. Wouldn't it be
What is the
max?
velocity? Identify. Okay. Identify the velocity at point L. What will be the velocity at point L?
U. Half
Okay.
mu
So what
square.
will be the time? Okay, half mu squared. Okay. What will be the Harish? What will be the potential energy at point L?
MgL.
Mgl. No, L is a point. L is not the height. L is not the height. What will be its potential energy at point L? L is considered as the zero. L is the reason is L is considered as the ground level.
Okay, we've got it.
Imagine with your okay. So L will be the lowermost point. So its height h will be equal to 0. Is that clear? Mahesh, is that clear? Mahesh? Sorry, Mahesh is the other class. Siddharth? Siddharth,
Yes, ma'am.
is that fine?
Yes, ma'am. Very clear, ma'am.
Okay. What will be total energy at point P? Zero. What will be total energy at point P? Again, it's kinetic plus its potential. What is the kinetic energy of the mass at point P, Zuhair? What is the velocity of the mass at point P?
V.
V. So what will be its kinetic energy at point
Half
P?
mv square.
Okay, half mv squared. Okay. At what height is point P with respect to point L?
H.
At what h? So what will be its potential energy? What will be its potential energy? At what height it is about the point L?
mgh.
Okay, mgh. Fine. Is it Zuhair? Is it Zuhair?
Yes, ma'am.
Okay, fine. So now half mu squared is equal to half mv squared plus mgh, right? Now from here, you get me an expression for v. I want everyone to do this. Get me an expression for v. Prasanna, get me an expression for v. It's others have to. Cancel of m is the common term. Cancel of m. Half, if you want to cancel off half, then you have to multiply. Just get me an expression for V. You do by yourself, boys. Let me check. Vishal, your microphone is working. Okay, did anyone get an expression for V? Boss, did you get an expression for V?
One second.
Okay.
Yes, ma'am. I got.
What is
Ma'am, root of u square minus 2gh.
Are you getting this? Are you getting V is equal to root of u squared minus 2gh?
Yes, ma'am.
Was okay. Now, first, what we have derived is velocity of the object at point P. So next will be the tension acting along the string at different points, right? So first we have found what will be the velocity of the stone at any point P. So next we'll find what will be the tension acting along the string at various points. Next subheading. Next subheading, tension along the string at any point. At any point, for that matter, we'll take the point P. Tension along the string at any point.
Ma'am, could you show the final expression for V again?
V is equal to root of u squared minus 2gh.
Yes, ma'am. Thank you.
When the body reaches the point P, there are two forces acting. One is its own weight acting in the downward direction, that is mg. Then tension is acting along the string. So forces acting on the body at point P are the weight mg acting vertically downwards and the tension along the string. There's no need to repeat the diagram. Only one diagram is enough because it's comfortable for me to put the diagram every time when I'm deriving. That's the reason I put the diagram once again. Only one diagram is enough. You can refer that. Just write these points, boys. Then we'll find what is the tension along the string. Just complete these two statements. Now there is a question. Okay. What do you mean by centripetal force? Any force that is acting towards the center. Now this force is very, very important whenever a body moves in a circular path. Whenever a body moves in a circular path, for the body to move in a circular path, there should be always a force acting towards the center. We call it as the centripetal force. Now I have highlighted a line segment. Now I just want you to get P and X. What will be the centripetal force? Looking at the forces acting along the string, because your centripetal force will always act. This will be a, because it only just think what, just once again. Partly you're correct. Just think. Partly you're correct. Okay. What constitutes the centripetal force?
How is it tension, right?
Okay, one person. Okay, fine. One has told me mg cos theta. That is partly correct. The other person told me it's t. That is also partly correct. I want look in which direction centripetal force is acting, and there are two forces.
T minus
So what?
mg cos theta.
Correct. Who is that? Who was that?
Ma'am, Sanford.
Sanfa, correct. Right? Boys, the centripetal force is acting towards the center. Now, suppose if you still find it difficult, suppose I have a body, right? Here you're pulling it with a force of 5 Newton. Here you're pulling it with a force of 10 Newton. Okay, totally in which direction the body will move? The body will move in the direction of, say, I'll just take it as 8. The body will move in the direction of the upward force, this force, right? With a force of 2 Newton. Yes or no, boys? You're pulling it on top with 10 Newton, the lower part with 8 Newton, because the upper force is more, so the body will try to move in the upward direction, but with a force of 2 Newton. Same way, can you see the highlighted line, boys? Can you see the highlighted line? Can you see the highlighted line? Right? Right? There are two forces. One is the tension acting towards the center, then mg cos theta acting away from the center. Your centripetal force is always towards the center. So your centripetal force will be a combination of T and mg cos theta. So now again, what can I write, boys? Next slide before I go for it. It's your work to do. Centripetal force must be equal to what? T minus mg cos theta. Do you understand why it is T minus mg cos theta? Because the centripetal force is the resultant of T and mg cos theta. If centripetal force would have been, if I would have had centripetal force, suppose if I'm having, this cannot happen. Anyway, if I have a centripetal force acting downwards, then your centripetal force would have been mg cos theta minus T. Are you clear, boys? 11b. If your centripetal force is acting away from the center, then your centripetal force would have been taking an expression mg cos theta minus T.
Ma'am?
So it is T minus, yes?
Ma'am, over here it is 0, right? T minus mg
Which is
cos
0?
theta. Supposed to
It'll
be
be
0. Because it doesn't
no,
move inward or outward.
It's balanced, right? Is it not balanced?
Yes, ma'am.
It's balanced. Can't say
okay,
0. 0
got it,
means, sorry, 0 means it will not move. It's a balanced force. Okay. What is the expression for the centripetal force? No problem. What is the expression for the centripetal force, boys? Is it not mv squared by r? Is that not mv squared by r? Okay. Now I'll leave you the next expression for you people to do. Right? Let me see how far you people can do. Boys. Now, are you getting this expression? It's only a few minutes left. I'll just finish this off and I come back. I want in between you have break. Just complete this. Let me see who can do this. mv squared by r is equal to t minus mg cos theta. Is that clear, boys? mv squared by r is centripetal force. Now, my aim is to find what is the tension acting along the string. That is your aim. Now, what I have to do is you consider triangle ONP. Can you consider triangle ONP? You find what is cos theta. Are you clear, boys? Once you get this expression, I want you to find cos theta from the triangle ONP, where OP will be the radius. Where OP will be the radius, ON will be equal to R minus H. OP will be the radius and ON will be R minus H. Then in your first equation, the previous one, you have derived an expression for V squared. V squared is equal to U squared minus 2GH. Is that so? Joe Paul? V squared is equal to U squared minus 2GH. Did you derive in the previous expression? Paul?
Oh, yes, ma'am.
Okay. In the previous expression, you have gotten previous derivation, you have got an expression for V squared. V squared is equal to U squared minus 2GH. Did you get that?
Yes, ma'am.
Okay. So you have to substitute for V squared. You have to substitute for cos theta. How will you find cos theta? Now consider the triangle ONP. OP will be the radius. Find cos theta. Adjacent side will be R minus H. Substitute for V squared. Substitute for cos theta. I think so. 5th period is your class. I'll check with everyone. I want an expression for T. It's 8:40.
Yes, sir. My math class started.
Okay. You can go for your max class, but when you come for 5th period, I want to check this. Thank you, boys.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you, boys. You can leave, boys. You can leave.